Hey there, YouTube. This is SJM4306 back with another video. Sorry, I've been kind of MIA recently. Needed a bit of a, I guess, vacation or whatnot. I haven't really had a break since, oh God, I don't know how many years. And, with the whole coronavirus shutdown, everything going on, life handed me a short break. So I took it. So anyway, what was I saying? Yeah, so I took a little bit of break, working on some projects still, but I'm kind of held back by the fact that it's really difficult to get parts through the mail. A lot of my parts are modules that come from China, and unless if I buy them locally, and that would cost like maybe 5 to 10 times the cost, I would have that would be the only way I could get it within like a week's notice. A lot of the stuff that I ordered, I'm still waiting for, and I ordered it in like maybe January or February, and still not here. So I have no idea if it's lost or not. Anyway, that's not the point of this video. That's just an update. So the point of this video is my sister bought me for my B-Day last year. Really cool glow-in-the-dark filament, and you can see this is luminous blue, and it's Hello, what is this? Hello 3D branded filament. And this spool, it's pretty small. It's only about 200 grams, I believe. So I can't print anything massive with it. And I thought it'd be really cool to print something functional out of this. So that's exactly what I've done. So that's exactly what I've done with this attachment. For this is just one of these cheap LED flashlights. It's telescoping, it's adjustable, it has a couple different modes. This specific one is Ultra Fire branded, and I use this a lot actually. And I kind of wanted a way. I usually, if the lights go out and I need to like shower or get ready for work, that's happened a few times. I would just stick this up and like stick a plastic bottle on top to diffuse, and it's not very effective and it falls over and whatnot. So I wanted to actually print an attachment to turn this into kind of a lantern, and that's exactly what this part is here. And it doubles as a stand as well, so it can stand on either end, and it works kind of just like a torch. And I'll fire it up right now. You can see it's quite bright, and if I turn it off, you can see that blue glow there. And yeah, it is actually glowing in the dark. And it's not super bright, but it's even, if you charge this up for a minute and then turn off the flashlight, you can actually still see, you can like read by this light. It's plenty bright enough for like an hour or two. Anyway, it's something that I thought would be kind of neat. It's both a diffuser as well as like a glow in the dark torch sort of thing. And it just fits on top using little slits on the side. And I just sized it perfectly so that it just sticks on like that. And so I thought I would do the same thing. Give me a sec. Thought I would do the same thing for this tiny little flashlight here. I have no batteries in here. This is just a AAA battery, like a carabiner, with a little clip and whatnot. You can attach this to your keychain, and it's actually surprisingly bright and small, and it's very convenient. I wanted to make a attachment that goes on here that looks like a tiny little lightsaber. So we're actually going to fire up my computer, get SolidWorks running, and see if we can make an attachment that in the same way slides onto here. So let's do that. Unfortunately, it is like boiling hot today. It's like 90 something degrees outside. So I'm going to have a fan on me. So apologies if the audio is a little bit weird if you can hear the fan, but I'm not going to be boiling alive in my room right now. So anyway, let's get started on that. So while we're waiting for this to boot up, one important thing when you're dealing with a physical device that you don't have measurements for, you don't have like a diagram or anything like that, is you're going to need a pair of calipers in order to actually measure stuff. Ruler might work in a pinch, but it's not going to be accurate enough to get like a tight fit like I kind of need for this cap. So you're going to need a pair of calipers. This one's just a vernier, it has a dial. And give me one sec. Okay, so I'm going to fire up SolidWorks. And I'm going to speed through some of this, but for the most part, I'm just going to let this run and explain what I'm doing. I'm only basically a beginner in terms of how to use SolidWorks. A lot of the things I'll be doing wouldn't be the most efficient way of doing it, wouldn't be effective necessarily, but it should work out just fine. So we're just going to create a new document here. it's a 3D part. And there we go. I'm just going to go normal to the plane, and we can start our sketch. So the easiest way would just be to make a cylinder and then round over the top. I kind of wanted to try using the revolve function so I can make it look more lightsaber-ish, where it's slightly tapered at the top. So what I'm going to do is sketch a profile, I guess. So let's just take a measurement of the cap right where it'll actually line up. So here it's pretty much spot on 15 millimeters. So to represent that, I'm just going to draw a circle. And I'm going to set it to the center point. And then 15 millimeters would be 7.5 radius. And there we go. So this represents the circumference of the actual flashlight tip itself, and that's what we're going to be attaching to. So from that, I'm actually going to set this for construction, and we're actually going to draw on the same plane, so it'll be a little funky, but just deal with me for a second. So I'm going to want to taper this tip. We're going to set it somewhere up here. And if that was 15, let's go for maybe 10. So we'll set this to 5. And we'll set the distance between them. Let's just see if the length of our flashlight is about almost exactly 90. I think doubling the length would be fine. So I'll set this to 90 as well. So we'll just fix that in place. This is save. Okay, so what we're going to be doing is drawing a line between these two as like a tangent. There we go. Okay. And a quick tip if you want to kind of be lazy is I can always draw a vertical construction line, and then if I deselect this, I can always mirror something about it, so I don't have to draw it more than once. Okay, so we'll go with this for now. I might have to tweak the diameter just to make it look better, but that should be fine. So I'm going to, with this, now I have sort of a box shape at the bottom, and I'll just get rid of these reference lines. So there you go. So we have that done. There we go. That sort of looks how I want it to. I'm expecting just kind of like a stubby little lightsaber. I could actually make this extendable so that it's basically a bunch of concentric cylinders, and when you pull it out, it kind of friction fits. Oh, there we go. That was weird. And so I could do that. That's more complicated than I want to bother with. So we're just going to leave this as it is. And let's see, how are we going to do a revolve? Okay, so yeah, it looks like we have our sketch here. I can just do a revolved. Oopsie. There we go. So I can revolve the shape. Okay. So actually, I've realized 15 is the inner diameter of the shape that I want to make. So I need to add at least, I want to say, let's go with 3 millimeters outside of that. Okay. So I said I wanted to add, let's just go normal to this, and I shall sketch on here. So I need to make a 5. Okay, yeah, so 7.5 is the exact diameter of the flashlight cap. So I'm gonna want to put a tiny little bit. Let's just see, something like 0.5 maybe. 0.6. Yeah, let's just add like 0.55 maybe. So this will be the clearance. So this is the actual diameter of the cap. This is going to be the inside wall of our part. So there's going to be a tiny little bit of space in between, just so that we don't make it too tight fitting. So that should be fine. We'll see. So anyway, I have this hole now, and I want to do an extruded cut. So we're actually going to be cutting up into the solid body. And this is way too much, clearly. Maybe about 15 millimeters. And we'll cut that. So it looks like we have a cap that'll sit on top now. We need to actually make some cuts. So in my original cap, I had 4 little slits to allow the material to expand slightly so it can fit over the cap and not, you know, put too much pressure on the cap or possibly split the plastic. So what we are going to have to do is, let's see, where's our reference plane? Is it? Yes, good. So our reference plane is dead in the middle of our body. So I'm going to sketch on that again. And this time I'm going to insert little squares into them. So the cap, basically, it's flat and straight, and then there's some kind of knurling so you can grasp it. Let's just figure out, that's pretty much almost 9 millimeters. So let's just figure out, and since we said we had 3 millimeter walls, I have to make it 3 millimeters. I'll make it a little more. So it cuts all the way through. And if I go to extruded cut, you'll see it'll cut only on one side. So I want to do mid plane, and let's just see, like this, 3 millimeters as well. Well, there. Because I didn't drag this out far enough. There. There. So now we have a notch. We have one. This might be too tight of a fit, so I might do the same thing that I did. So let's just go with, let's see, can I do a linear circular pattern of this? Features to pattern. There we go. Okay, so I just had to select the face in order to have it revolve around there. So if I go here, then it created all the other notches for me without having to change the plane and keep drawing on each plane. So now I have each of these tiny little clips that'll basically hold snug, hopefully, if I have my measurements correct. And so all we have to do now is save, and save it as an STL. As an STL on my desktop, and yes, yes. And let's open Cura. Okay. Obviously we're not going to print in this orientation. So I'm going to rotate this vertical and bring this to the front of the printer where I have my glass sheet, and this will take an hour or 10 minutes at 0.25 millimeter height. I don't need this very high resolution, I just want it to print quickly, and 20% infill should be fine. There shouldn't really be much to infill though. Yeah, so 11 grams and 1 hour 4 minutes. And even though there is sloping, I actually don't think I need any support on this. Even though there is a sloping surface, it's pretty gradual, and at the top, the diameter should be small enough it should easily be able to bridge. So I'm just going to print it like this. Now it dropped down to 59 minutes. So within an hour and 11 grams later, we should have a cap that we can test that'll fit on here. But let me just save it onto the SD card for my printer and get the printer set up, and we'll get going on that. Okay, so we're at my printer. I'm just gonna start preheating for PLA just so that I can pull. I have black filament in here right now, and I'll do a quick purge. Now I'm printing on a glass bed that's, well, this is actually from a picture frame from the dollar store, and it's just a thin sheet glass, and I took the glass out, and I'm using these binder clips to just hold the bed down here, and it's nothing critical. It's just kind of laid down there, and I sprayed some unscented, let's just see, also from the dollar store, unscented extra hold hairspray, and just any hairspray I think will work pretty much. Unscented is better, just because it doesn't have any weird additives in it, and it adds like a very thin layer of some kind of like, I don't know exactly what it's made of, but some kind of like polymer or something, and it'll allow the print to stick to the smooth glass a lot better. So once we get up to about 180, I'll do a cold pull of this filament to get as much of it out of the nozzle, and then we'll insert the glow-in-the-dark filament. So give me 1 second on that. Okay, and let's just pull this out, and you can see leaves a little daggy in there. So I'm doing this with one hand, so let me get the other filament and get ready to feed it in. Okay, so I have the other filament in. I'm just gonna push it, and you can see the old black filament going in there, and I'll just keep pushing it until it goes kind of that clear color. And there we go, that should be good enough. So you can see here that transition from the black filament, it gets lighter and lighter, and eventually it turns into the newer filament. So we should be ready to go. I like to usually pull the filament back like 3 or 4 notches, otherwise it starts leaking out the bottom of the nozzle there. And if need be, using a pair of tweezers, you can just kind of grab the little booger off there. Okay, so it looks like we're almost up to temp. So I'm gonna go to print it, and what did I call it? Lightsaber flashlight, something or other. And for some reason it bumped my bed temp like way up. So let's just bump that back down. I think because I was printing in ABS before. 50 is good enough for PLA. Actually, I could print on a cold bed, but the edges do curl. So anyway, this is just gonna take a couple of seconds. It's gonna bump that temp up to I think like 210. I have it set for this filament. Apparently glow-in-the-dark filament takes a little higher temperature to melt. So anyway, once it gets started, I'll resume filming. Okay, so any second now, it'll reach the target temperatures, and it should start homing. And it'll auto level. It's just homing all the axes. It's got to move down the Z, which takes the longest because they're on twin lead screws. And it'll start homing away. Okay, and it's starting now. Now I could actually play with the retraction settings and kind of prevent those boogers from skipping out, but whatever. So it looks like it's beginning to print. It's doing each of the 4 legs right now. Let's just grab a flashlight. Let's see, it's doing the 4 legs. But yeah, let's just let this go through, and I'm not going to bother doing a time lapse of this. This won't be that interesting. But I'll let this go through, and an hour later I'll show you guys the end result. Okay, as you can see here, it took just under an hour, 55 minutes, so pretty close to the estimation. So yeah, not bad all in all. And it's just on the bed here. This will probably peel away pretty easily. There we go. Okay, and here we are. And the finish, it's not perfectly smooth. I forgot to adjust the acceleration settings on my printer. I usually slow down the acceleration so that it doesn't vibrate a lot, because of how I have the printer mounted on top of like a table that's not very secure. It'll vibrate with the printer if it moves too fast. So I usually slow it down. I forgot to do that, so there's like a lot more surface ripples. But this is going to be a functional print. I don't care really how it looks. Let's just see, moment of truth, whether it fits or not. So as I was afraid, it looks like there's little elephant feet. I am going to need to sand them down on the inside. They're preventing this from inserting. So let me do that off camera. So give me a sec. Okay, so I sanded down the inside. I just took a pocket knife and I scraped. The calibration for the actual head height over the bed must have been a little bit too low. There's quite a big like elephant footing as I thought there would be. So basically just means everything gets squashed and kind of fatter than it should be. So there's a lot of extra material inside that I had to kind of remove, and I sanded it because it's actually kind of sharp and actually poked me. Anyway, so yeah, the fit I made a bit too tight, but actually that's probably a good thing. Once you get it on here, it's not coming off until you actually pull it off actively. So this is on here solid. I can, throw it around and whatnot, and it's not going to come off accidentally on its own. So that's probably a good thing that I made the fit a little bit tighter. It'll loosen up probably with use anyway. But anyway, yeah, it fits there. It fits like right to that knurling as I wanted it to. You can see it actually can screw and unscrew using that. Anyway, let's turn it on. So you can see the auto exposure on my camera instantly, kick in, because this is actually quite a bit bright. But yeah, definitely you could, in the dark, this would light up a room pretty easily. And you can turn it off and you can see it continues to glow blue. So let's take this in absolute pitch dark and give it another test. But so far, I'm really happy with how this is working. Okay, sorry if it's echoey, but yeah, you can see it's still glowing. It's been like 2 or 3 minutes since I last fired this up. I'm in my bathroom right now. But yeah, you can see it's still glowing. It's like a little lightsaber. Pew, pew, pew. Anyway, so yeah, you can see here, I can turn it on. You can see my wallpaper there. And yeah, this lights up, plenty enough. This is, brighter than a candle. You can stick this on, your countertop sink, and if the electricity went out, this is plenty enough to be able to, use a dark room and even read by if you wanted to. And this will work. I don't know how long this flashlight lasts on a AAA battery. Probably not that long. Probably, I don't know, 2 or 3 hours, something like that. But I'm using a rechargeable in here, so this is definitely really useful. You can have this just clipped to in your pant pocket or something like that, or on a keychain. And when you turn it off, you can still see it glows. And you can just about see, just from the glow, you can actually kind of see detail and read by, and it's clearly visible like as a marker. So this actually works really well. I'm really happy with that. You just see that now. How cool is that? And obviously this is the blue color. It appears more blue. It's kind of slightly aqua-ish in real life. It appears like a more solid blue color on my camera, but I can assure you this is sort of an aqua color. And if you get the green glow-in-the-dark filament, that'll actually glow brighter and longer, because the chemistry for the green glow-in-the-dark material is actually a bit more efficient than the blue one. And plus your eyes are much more significantly sensitive to green light than blue. But yeah, you can see this works plenty fine enough, and this is actually really cool. So I'm really super excited about this. This project worked out real well. It took me a little longer than I'm proud of, faffing around with SolidWorks to figure out how to get it to do the revolve correctly. But, you know, that was my first time using the revolve tool. I usually don't. I just usually do kind of more squared geometric shapes. So it was cool learning how to use that, and it worked out really well. And now I have this tiny little lightsaber thing on a flashlight, and it looks really cool. So yeah, there you go. Anyway, hopefully you guys enjoyed this video. Just got to get this edited and uploaded. Ooh, rubber pencil. Anyway, and I'll see you in the next one. Bye. Okay, quick addendum. You can't show glow-in-the-dark stuff without dousing it in UV and showing just how bright it could glow. Now, obviously, a lot of people tend to use UV flashlights, but I thought if you're going to go big, go very big. So I'm using my UV cure box for my 3D printer. So let's just stick this in for a little while and let it charge up and see how bright it gets. Should be good enough. Look at that. Look how bright that is. You can even see it glowing